All right. Thank you for joining today's call. We're going to be having an additional session today on technology profiles, and Sean Massetta is going to be leading that. And as a reminder, we do record these sessions. They'll be posted later to the VOLTHA playlist on YouTube, so keep that in mind during the discussions and presentations. And with that, Sean, I will hand the meeting over to you.
Okay, thank you. Just gotta do a little adjustment here. Let's see. All right, just gonna bring up the agenda. Okay, can you see the agenda?
Yes.
You notice that this is version .2. So, okay. So basically, the idea of this meeting is to kind of walk through some of the architectural issues, kind of that we need to address from a technology profile perspective. We can hopefully answer any questions or address any questions, take notes on what other issues that we may need to solve. So first of all, I basically, just for everyone's benefit, I put all the basically a bunch of documentation and presentations in the Vol 731 EPIC that represents the technology profile architecture or requirements. So Vol 731 has a whole bunch of attachments now. There's the latest ones were around a presentation that Netsia had provided around. They did an analysis of the all the JIRA stories for technology profiles. They did a nice job. There's a recording of that meeting that I'd referenced in the agenda as well. So if people want to listen to that, they can. So if when needed, I was going to reference their presentation as well as we talk through this. So the agenda is basically organized in terms of the JIRA stories themselves. So 732 is the first story under the EPIC. So this one basically is adding support for technology profile reference using a flow table, upstream, downstream bandwidth profile definitions to a subscriber record at the ONOS level. So this story basically requires the addition of a table ID as a technology profile reference to this status record. We need to add upstream and downstream meter information. But based on the story, Gamze from Netsia had put together a few slides on this also. So there was a description of what the ONOS application changes would need to be around the status record. So here you can see, is that visible to people? Is that big enough? Or?
Yes.
Yeah, looks fine.
Okay. So here we see, the existing status record information, and then Gamze had highlighted and read the proposed changes. One was a table ID, which was there's a reference to a technology profile, and then basically an upstream meter band and downstream meter band. As part of the discussions around this, we've kind of said that, well, maybe we just need a reference to a named meter band. So basically, typically the operators have a bandwidth profile that's referenced from a subscriber record. So there'd be a downstream reference and an upstream reference. So instead of having the bands explicitly, detailed inside each status record. There's going to be a reference, and then the reference basically avoids any mistakes that someone might make. So basically, subscribers who have the same service tier and the same kind of bandwidth profiles just have a named reference. So that was one proposal that kind of had been made there, and that's kind of detailed a little bit in the agenda item here. So what do people think about that? Because the virtual OLT on ONUS is going to have to go and read the status record. It's going to have to go look up that named reference. It's going to have to translate the information in the bandwidth profile to meter bands, and obviously someone has to manage those records on ONUS as well. You have to create them, delete them, change them, right?
So again, the status records can be managed by ONUS. That's really meant for demonstration purposes. Status is meant to be an integration API. So those records are really meant to be a REST API call out to the VSS OSS to get that information.
Yeah, sure. Yeah.
Right. So they're not really managed in ONUS from that respect. In terms of the bandwidth profiles, as a reference, are you looking at that as kind of just another key in the key value store that you just do kind of a second lookup at?
So yeah, I would imagine that they're just a record that's in a database. But I guess it would be either on ONUS or it would go off platform to some other data store and read what that bandwidth profile is, I assume.
Yeah, that's what I'm saying. Is it just if the bandwidth profile is just another JSON structure, we can also just put it in key value store and be done with it that way. I wouldn't store it in ONUS. Is there any reason we wouldn't put it in the key value store? I mean, it'd be like a table ID here. You're really referencing another record somewhere else.
So the only issue with that is that ONUS needs to be, or an application on ONUS needs to generate the open flow messages that have the meter band information. And so if we define the bandwidth profiles in terms of traditional EIR, CIR type values or AIR, then that needs to get translated into meter bands for a given meter, and ONUS needs to do that.
Right. Is a concern having ONUS call, or this application call out to the external database? Let's back up. It's the OLT application that's going to be doing this, yes?
Yes.
Is there a concern about it calling out to? I mean, it's calling status. So the question is, do we just bundle that all in one record in status, or it can we can expand that interface, that integration interface. So from the VOLT perspective, it's calling out to a REST API essentially. It doesn't know where that's served from.
Yeah, and I guess it also gets back to a comment I think you'd made one other time, David, around where does the details around say the meter bands, where does it manifest itself, right? I mean, if there's a call out to some external database or some call to an OSS BSS type system, then I mean that could have the bandwidth profile provisioning, and then that gives the detail in the status record, and you don't see the profile itself. You just see the details and the error checking and everything. That's all handled externally, and the details appear in the status record. And we don't have you don't have a bandwidth profile that exists on ONUS or exists somewhere that could be read by an ONUS application.
The only thing you'd lose on that is some ability to, I'm trying to think, because they're all expanded out in the ONUS record, if you change the profile upstream, you don't really know who's changed downstream. You've kind of, at least from an ONUS perspective, you lost the connection.
Yeah.
From upstream, you wouldn't. I could go either way, I guess.
Well, is there anyone from ONF on the call that could talk to this a little bit, or that's worked in these applications on ONUS? Well, okay. Is there a working decision we could make for now that there's maybe? I mean, I was thinking that you could have you could build a bandwidth profile somewhere that could be you could call out and get the details of the bandwidth profile, and then you'd have a reference in the SADIS database. I mean that way you don't have to have all the details in every record. You just have the reference.
This is something that you can query the OSS, BSS, get it as part of the plan information, right? And so, for example, part of the workflow we're talking about is to build in the ability within XOS or NEM to be able to call out to the OSS, BSS, get the plan information, and then possibly feed that to underlying systems like ONUS.
Yeah, so I mean the goal is to be able to generate the open flow messages, right? We need to create the meters and the meter band information. So basically and again, this is Gamzee's presentation. So here was a slide showing the EAP message going upstream to ONUS and basically accessing the subscriber information from SADIS. Then the VOLT goes and sends the rules to Flow Manager and the OLT driver and generates the open flow messages, right? So at some point in here, presumably maybe VOLT goes and gets and decomposes the reference for the bandwidth profiles and goes off platform somewhere else, right, and gets the information, and then it sets up the meter bands.
And I think you said in some of the emails, or maybe I don't know who said it, there's a very limited number of these bandwidth profiles anyway, right?
There should be, yeah. I mean,
so it's possible for the VOLT driver to essentially preload those. So there's not really an external lookup at runtime. As part of its startup, it could somehow say, go read all the bandwidth profiles, and then just cache those in terms of references. And when it gets them, just use whatever it needs. I mean, that's an implementation. It doesn't have to be that way, but that is an implementation.
Yeah, but they obviously have to be able to be modified or deleted or added to, right? Okay. I mean, is there any, I guess, preference at this point? What would be?
I mean, there's already a precedence in the status record that it does a reference, right? Because the table ID is a reference.
Yeah.
So why not just continue that? I mean, it is JSON. You could do the very interesting thing is say, look, if you have a reference, you obviously look it up somewhere else, but you could always inline it as well. And the code just has to make a choice.
Okay, so I guess if the reference doesn't exist, then we'd have to go get it from somewhere, right?
Yeah, and again, from a simplicity point of view, I just say, hey, look, just like we have a profile structure in the key value store, we could define a schema in the key value store for the upstream, downstream profiles as well.
Okay.
That's my preference, but not that it has to be that way.
Okay. Oh, that sounds reasonable to me. How about anybody else have a preference or a comment on that? Okay. So I guess we'll use that as our working model, I guess. Basically, there's going to be a reference in here, and basically, it'll be up to the VOLT to either preload it or go get it if the reference doesn't exist. But we'd have to obviously configure information around where that would have to go to get that information, right?
Sean, this is Mesut. The table ID will reference downstream and upstream meter bands, right? And each table ID can have different meter bands. Is it correct?
It could, but yeah, but there should be a limited number of those.
I mean, different subscribers can have the same table ID information.
Yes, they can.
Yes.
Yeah.
Okay. Yeah. In this case, this can be a reference number for these meter bands. Yeah, I can agree with this opinion.
Okay. All right.
Hi, Gamze.
Oh, hi, Gamze. How are you?
I think I updated this slide. So if you make me presenter, maybe I can show that.
Okay.
Thanks.
Is there something you need to do, Julie?
I should be able to. Give me 1 second. And Gamze, are you ready?
Yep.
Okay. Okay, you should have presentation rights now.
Can you see?
Yep.
Yes.
Okay, good. I think this is the new one, the newest one. And I think the table ID represents the technology profile ID, and it includes GM port T-count details, the scheduler and buffering algorithm details. And I think the bandwidth profile is different from the table ID. So we can use meter profile name, such as 100 gigabit per second, I don't know the name. And virtual IoT application gets this profile name and asks to a database or another configuration file. I don't know, but it can get the details, right? Yeah.
Yeah. So I guess the issue was, so if we go with this approach, then basically, VOLT would have to be able to go and essentially get what 100 gigabit means from a database. Either exists locally that it already has that information downloaded, or has to go off platform somewhere else, right?
It sounds good for me, but I don't know others.
Now, the only thing with the definition of the meter bands here is that we need, well, I guess we basically need a number of meter bands, right? So you either have one or three if you want bandwidth control. The question is this the format that the operators would like to see these bandwidth profiles in? Or would they like to see it in a more, I guess, traditional type of definition? So, like the MEF type model, or basically, EIR, PIR, EIR, CIR, AIR.
Yeah.
So I guess I was assuming that it would be, like a standard type model for defining what the bandwidth profile would be, and then some application would then translate that into the meter band definition for downloading.
Okay, it's not a problem.
Yeah, I think it works either way.
In this example, we have a single meter profile that maps to both upstream and downstream. And again, that's more of a question for the carriers. Do they want to be able to specify those as different profiles, an upstream profile and a downstream profile? Or that's a single profile? And again, that's a carrier question.
So we may need to take that back on VOLT to discuss, or during one of the other usual meetings in order to get a response. I don't hear anything at the moment.
Yeah. Okay. So just
track that as a follow-up question for the operators service.
Right. So meter profile, is it one unidirectional or is it bidirectional? Potentially. Okay.
I think this is related to upstream. So downstream, I don't know, downstream is in OLT or ONT?
Well, downstream traditionally is not. I mean, it's not managed via the traffic descriptor for DBA on the PON, right? So it's usually external in another, usually in another part of the OLT, but it could be, completely external in a BNG type function. It could be located in multiple places.
Okay.
For the edge core, they have the ability to do downstream shaping in the NP part of their system. So in some cases you want to supply both upstream and downstream.
Yeah.
Okay. So I guess that's a question for the carriers to resolve. Now let's see. So the other question we'd actually had in the previous meeting was this meter band type. So and the question was, because we're shaping in the downstream, we don't want to police away, we don't want to drop packets if it goes out of the meter band, and we don't want to remark the packets with a other DSCP value. So this meter band type is actually optional. You don't have to specify that. So if you want to do shaping, you don't specify that at all, and then the packets will be shaped to the rate instead of with no action if they go outside the bounds. Okay, can you just give me back the presenter?
Yeah.
And okay, you see my screen now?
Yes.
Yes.
Okay. Okay. So if we go back to let's see, 732. I think that was the issues that were kind of outstanding there. Are there any kind of questions on the 732? I'm sure there probably are. Actually, yeah. So one issue around this one was again around the on startup. Basically, once the ONU is discovered, right, and we authenticate, and at that point we really need to assign a default TCON and GEM port to the ONU port. That needs to do the authentication, because otherwise you can't send anything upstream. Right now we give it there's some default GEM and TCON that's used to send upstream the authentication messages. One suggestion was that when the ONU port is discovered, we could, along with setting up the the EAP message redirection to the host, the controller, we could also set up the default technology profile to allow the ONU to send traffic upstream for authentication. Are there any thoughts around a preference for that?
I'm not sure I understand the question. What do you mean, preference for that?
So right now we have a default model for when an ONU is discovered. I know a GEM port is assigned and a TCON is assigned, ALEC ID is assigned to that ONU port, right?
Mm-hmm.
So one thing we can do on discovery is to assign a default traffic technology descriptor, technology profile, sorry, and basically that profile defines a TCON and a certain number of GEM ports that would be allocated to that port on the ONU, and that would be used to send upstream any authentication messages that would be needed. We could make it such that the default is going to be the same as the service technology profile. So if you use 255 as the default, then we'd use 255 for the service as well. So then there'd be no difference.
I guess the question is, where's the 255 is coming from the status record for the map? Presumably at that point.
Yeah. So basically, 255 would be the table ID for the service here. But if we use 255 as the default, like this would be per operator, right? So if AT&T has a default of 255 and they use 255 for their service, then that would be set up per operator. Somebody else may have a different thing, but
right. What's the value of having a default one if we know the service, the actual profile that's going to be used? Why not just use the actual profile from the get-go?
Can we derive that from the discovery? Because basically we're essentially adding a port, and there's a serial number that comes up, and presumably that somehow
right. If you go back to the status record, there's two keys. So there's a Uniport ID, which is, and also I think there's a record in there that you can look up by the serial number as well. So I think you're essentially looking at the same information. So you at this point you kind of know from the physical connectivity what service it's going to eventually end up with, and it's just the authentication that's determining which flows are pushed down to allow which traffic, I would think.
Well, I guess we'd have to. So what comes up with the port add is the serial number and potentially a registration ID, right? So that serial number somehow would then have to map you to the correct subscriber information.
Right. I'm trying to look up where because if you look at the status, there's actually
and a port number as well.
There's two records. Let me find it. there's two keys to somewhat similar information, which is unfortunate, but I gotta find out where that is. So one is this, by the serial number, I think, in it right now. Here, let me put that to chat. It's just a GitHub reference to the README there. So if you look second record, that's towards the bottom of the page, there's a configuration parameters entry. And it looks like, I'll cut and paste this as well. And it's got two entries. One entry is...
Do you want to just show your screen, David? Or?
Well, I put it in the chat if people,
it's in the chat? Okay. All right. I see.
There's a ID by the Uni port, but there's also an ID which essentially is the serial number of the port. Now, unfortunately, that would mean ugly things like there could be potentially repetition of data if you put the table ID in each place, I guess.
Yeah, absolutely. Uni ID one. Oh, so okay, so there's two separate records.
Yeah. Unfortunately, well, and you could view these as one record with two indexes into it, because you could, when you query the status by the Uniport, if you got things like the hardware identifier, the IP address, and the NAS ID, it doesn't matter. The code that has done the lookup by Uniport will ignore it because it's just a JSON data from its perspective. It's just looking at key fields. So you could look at it as, and probably the better way to look at it is one record with two indexes to it, both the Uniport as well as the serial number.
Oh, well, Uniport, Uniport is with reference to a particular ONU, right? So the ONU is identified by the serial number or registration ID. I guess there's a MAC address in there as well.
Yeah.
I don't think are we using that? I'm not sure we are. But okay, so if we have the serial number and we have the string identifying the port number, then we would then apply the table ID, I guess. I mean, if everything basically references one record, the table ID would be in that record. So whichever way you get to it, you get the same table ID. So that would be ideal. Okay, so we index to status record and get the table ID. So basically on startup, as we provision the the authentication rules for the ONU, we also give it the table ID, and in that case we provision the OLT then uses that to create the technology profile instance for that particular ONU, and then it's free to communicate upstream and downstream. And then once it's authenticated and it gets the service rules, I guess the tagging information provision, then it's good to go, because even though the next flow references the same table ID, because the table ID is single instance on the Uni, it uses the same instance information.
Yeah.
So okay, yeah, that works good. And I'll write up all the minutes and send these out, and so that if I screw something up, you can fix it. But okay, thanks.
Or screw it up in completely different ways.
Yeah. Okay. So that was Vol 730. Any other comments on Vol 732 or questions or anything else? Okay. And Vol 733. So this was basically a story around basically passing through the OpenFlow data for the table ID for the technology profile and the meters, and doing error consistency checking on that. So when Netsia kind of took a look at this, Gamzee took a look at this, and basically it shows that the OpenFlow agent doesn't really store any of the OpenFlow rules itself. It passes those down to the core. So for any forward reference thing, it doesn't have the information locally to do any rule checking. And so unless you want to go and get the information from the core, which probably is quite an overhead, I would imagine, from a performance perspective, do want to let the core do the error checking for OpenFlow in the forward reference cases? Like the technology profile index that's used, does it exist in the key values stored for the meters? The meters, does the meter exist? So the OpenFlow agent doesn't have the ability to do that itself currently, anyway. So the suggestion that I guess from Netsia was to do it in the core, since that information resides there.
So the error would be is if we pass down something like a table ID or
yes, it didn't
exist.
Yeah.
So there's a couple options, I would think. There's one, do it in the core because everybody has to do it. Or the other option is the OLT is going to have to do the lookup. And when it does a lookup to something that doesn't exist, crash and burn, right? Error out. With the that kind of operates under the assumption that I'm not doing any error checking or I can do validation offline using other tools, but at runtime I'm going to assume my config is correct. Right? It seems to me that if we have the core do the check, it's going to say, oh, I got table 10. Let me look up. Does table 10 exist? Yes, great. Pass table 10 down to the OLT. The OLT is going to go, oh, let me go look up table 10. By virtue that it's looking up table 10, it is essentially doing validation in line. Right?
Well, I mean, I guess there's a couple of subtleties there, right? One is that does the core know the technology part of the lookup key? Because it might be table 10, but it may not be table 10 may not exist for technology, EPON or whatever. Right. But so once the OLT goes to look it up, that may fail.
Right. So I guess so what value is the lookup at the core then?
It gives you a partial valid lookup if we're only talking about one technology, right? Once we've got a multiple technologies, unless the core understands what the technology is for a given adapter, then it can't do a specific lookup.
I just let it fall through to the adapters, and the adapter tries to look up, it fails. There's no validation except when the adapter tries to look up.
Yeah, I think the adapter should probably do it anyway because it's going to have to do checks of does it have that resource anyway. And if it doesn't have the resource, then it's going to fail. And if the resource becomes available, it's going to have to reapply the rules. So the adapter needs to be the smart one.
Yeah, I guess my issue is even if the core knew all that stuff, the adapter is still going to have the same code, which tries to look up and fails when things doesn't look. So
that's what I'm
value in the core.
Yeah, and there are other failure paths, right? That was just brought up in that maybe the resources aren't available for that particular instance of a technology profile too. So okay, so we know the meter bands exist in the core, right? Those are those can
But
be looked at.
again, even the OLT is still going to have to do that same lookup if it's doing the translation of the meter bands. So also doing the lookup in the core doesn't help us. It's just redundant and wasting time because the OLT is going to have to do the same check.
Yes. Okay. So,
So
if we move all the error checking from that sense down into the OLT adapter, then we need to have a ability to report that error back up some way, right? I guess that would just be an alarm in that case, would it? Just
Yeah.
an error or something. So you wouldn't be able to catch it in the OpenFlow agent itself. You just have to fall through and then just report an error condition via some alarm about a resource or something similar.
Something, yeah.
Okay. Well, is that would that be okay with everyone if we just allow the OLT adapter to do these error checking for these kind of forward references? Because there may be resource issues. I mean, there may be other issues besides something not existing, and there may be resource issues around creating an instance of a service within that adapter anyway. Does that make sense?
I think it does, and if we can provide any status back in OpenFlow, that would also be about whether the flow actually works. Is there a mechanism in OpenFlow for that? I know within ONUS there is.
Yeah, I don't know if there would be any direct feedback, because once you're essentially creating the service, and once it's offloaded into the core, there's no real way to feedback unless there's an instant knowledge of an error, right?
Yeah, I just knew that in ONUS for their flow rules, they have the flow states or whether it's being applied, success or failure. So I didn't know if OpenFlow had the same mechanism or states.
I don't know. Does anyone know that on the call?
How to get the error state back? I mean, the ONUS has kind of a flow can fail to get installed on a device. I'm not sure how in our instance that would happen, right?
Yeah, I mean, it's going to be in the system, but there may those forward references may fail. There may be a resource issue that can't be applied. I mean, there's probably a few different ways it can fail. But is there any direct feedback if I send down an OpenFlow message that it was successful or it failed?
Well, again, in ONUS, you can say, show me all the flows that are pending add, or failed to add, right? I don't know how that. I'm not sure how ONUS captures that, I guess is my point.
Well, we can look at that later. I guess if worst comes to worst, we can always have a PM field indicating the state of a flow. So we don't really have to solve this now. I just wanted to bring that up.
Okay. We'll do a little bit more digging on that one. Sounds like we can, there should be some status that you can go and read about all the flows in their current state, I guess. But there may not be an instant fail or success with a given addition that ONUS has done, unless there was something that could be caught in the agent. Okay, we'll take that as a pending change. So, given that, I've probably changed the wording of 733 such that it's the message will essentially be passed through to the OLT adapter for validation, and that there may be some resource alarm or some other condition that would be notified northbound based on the status of that. Is that a reasonable approach?
Yeah.
Okay.
Sure.
Thanks. And then Vol 735. This was the one where so I cut and pasted the picture that Sienna had provided around re-architecting the core, and there's a question around basically accessing the technology profiles from the KV store by the adapters, right? And we also had a little discussion around this when Sienna presented the performance results. So I guess there was initially we were thinking, well, okay, the adapter can just directly go access the KV store in this diagram. It's etcd, and based on the technology, on the performance results, it was from my perspective anyway, it was a little ambiguous whether etcd was something we could go to the field with because of its its handling of these stress situations where it has a lot less memory and it has a lot of operations going on. Console seemed to handle that better from my understanding of the presentation. I guess there's some questions to the developers of etcd that's outstanding, some bugs, I guess. But it would seem like it would be prudent to have maybe a thin layer between the adapter and the KV store, so that if we do switch KV stores around, there's less impact on the adapters. Is that a consensus situation, or we still have questions around that?
I think, at least in my mind, it becomes the thickness of that, right? I'm almost of the opinion that if an implementation of an adapter chooses to abstract a call to the KV store through, a simple get put function that they have within their adapter, and thus if they want to change from etcd to console, they would change the code in one place and not at every get and put thing. Have at it, right? And if that 10 lines of code people want to share, it can be put in gist or someplace and shared. I don't think this is, let me put it the other way, I think this is trivial enough that it can either be left up to each adapter how they do it, and I don't think it needs a separate component to provide that access. Does that make sense?
Yeah,
you don't have, not that you agree, but does that make sense, I guess?
I understand, but so someone may want to step forward and provide that that trivial code for sharing, I guess.
I mean, there's a coding proverb that basically says, a little bit of copying is better than than a lot of dependencies. And I just don't think there's that much code here.
Okay. So any other comments or agreements, disagreements? Okay, so I guess we'll have a little judicious copying for Vol 735, I guess, from somewhere.
Yeah, and I thought there already was within the Python library kind of a little get put method wrapper around some of this stuff too that probably could be used.
Yeah. Okay. Okay. All right. So that doesn't seem like the end of the world, but okay. the next story was Vol 736. So the flow decomposer support pass-through of the flow table ID reference for technology profile and meter programming message down to the device adapter agents and adapters themselves. I think Gamzee had a nice picture around this one too. Thanks to Netsu and Gamzee for providing the presentation, by the way. Let's see. So I think this picture, Gamzee, was the one, right, where basically the flow decomposer is in the path here to support the open flow message decomposition passing down to the device agent and the adapter agents via the bulk flow call. So basically, in this case, we basically want to pass down the flow table ID that references the the technology profile, and also any meter band information that needs to go down to the adapter agents. So this story is basically just talking about we really need to pass down the flow table ID that references the technology profile and any meter band changes. So basically, this is basically adding support for passing through of these the new components that we're adding for technology profiles. And so, is there any issues with that? I think it's just a matter of adding in the TID, technology profile ID, and the meter band information to pass down to the OLT and the ONU. Okay, and the next story was Vol 737, the Open OLT adapter support for technology profile and meter support. So basically, here the Open OLT will basically take the open flow programming information. It's looking for the technology profile flow ID reference, and basically it can go and access the KV store and get the technology profile. The technology profile will basically tell the OLT adapter, hey, you need to go get an ALEC ID, you need to go get a certain number of gem ports. And then once the OLT has that information and the meter information and other information about the flow itself, it's going to create a technology profile instance. So the idea in that case is I have my resource manager for a given PON. I go request an ALEC ID, I go request a certain number of gem ports from the resource manager, and I then populate my technology profile instance with that information, plus any other specific information that's specific to the flow. And there's an example that I put in just recently to on the wiki showing a technology profile instance. Let me just bring that up. Let's see. So in this case, I'd added this on top of in the area that David had created the technology profile management. So there's a section on the wiki that talks about technology profile management. I'd updated some details around the JSON definition of what that technology profile would look like. So this is what would get created. Thanks for David for doing this as well. But so this is what gets created in the KV store for a given technology profile. So in this case, it'd be profile 255 for an XPON type of technology. So basically you get the instance control, the schedulers, all the things we talked about, the gem information, all that information is in the technology profile, both for upstream and downstream. And then, so the OLT then goes and reads this based on the flow ID, the technology profile ID that comes down with the open flow messages. And then it goes into the resource manager, and it basically gets the ALEC ID and the gem port IDs, and it creates a technology profile instance. So I added this section, and please comment on this. So this technology profile instance basically has all the information from the technology profile, but then it goes and also stores the ALEC ID, max gem payload size. This would probably come from a PON level configuration. So basically defines for a given PON what's the maximum payload size for a gem. And over the years it's just gotten bigger. So 1518 was a common one. Then recently they went to 2K, and then 9K JOMO frame type sized payloads. So I have a question out to I guess AT&T, and I guess the rest of the carriers also, as to what the payload size should be for the VOLTA deployments. This was whether using extended mode on a PON, that should be a PON level configuration thing. And then basically we have our upstream traffic descriptor for DBA. So this is derived from the meter band information. So the meter bands define, what fixed bandwidth, what assured bandwidth, what's the maximum bandwidth we can have in the upstream, what's the additional bandwidth eligibility. So those things come from the meter profiles and the form of the meter profiles. Or for additional bandwidth eligibility, I can specify that explicitly in the traffic descriptor if I want to. Auto just means I derive it from the meter band information. If I want to explicitly say I'll use this additional bandwidth eligibility, I would specify that in here in the technology profile data. Same thing for the downstream traffic descriptor information from the meter bands. This is derived from the meter bands. And then in the gem section, so for each gem, I have a gem port ID. This is allocated by the resource manager. I have, from a future-looking perspective, I can also use a gem traffic descriptor as well down on the ONU. So if I want to do any upstream traffic shaping on the gem itself, I could specify that I'm configuring a given queue from OpenFlow. We don't do that right now. We just specify a bandwidth for the flow as a whole. But if I want to specify a queue configuration, I can specify that, and then I can apply that as a traffic descriptor on the ONU itself for a given gem. But that's future. That's not what we're doing now. So each gem gets a gem port ID. So basically all the details of what resources are allocated are in the instance. And the OLT, I was thinking the OLT would be the one to create that instance.
So this is one area where I was wondering if there's a common toolkit that we could use out there that exists, kind of like a template interpreter, so that these profiles could be specified in some templating language, including the ability to indicate, hey, this value here should be retrieved by calling some method, some resource allocation method. Therefore, the processing of the profile to this instance would essentially be a call out to this templating engine. Again, I know there are these things that exist. I know various languages have one. I don't know if something like we could use Jinja, sorry, which is Jinja 2, which is kind of has implementations or at least APIs across multiple languages so that these technical profiles are essentially Jinja 2 templates with callouts, so that we don't have each OLT or each adapter trying to interpret the profile in its own way, right? Or we don't have to write our own templating. Is that something possible?
Yeah, I'm certainly open to that. I mean, I don't know about anybody else. I mean, that if that helps speed the implementation, that would be great. I mean, I haven't used that myself. You know, I'm familiar with XML, but nothing. What's it called? GING2?
JINJA 2.
Oh, okay. I've seen that before.
Yeah,
okay,
but does it pretty much do the report? Basically, does the reporting? It doesn't do the parsing to read it back in. So it's like, wouldn't Jinja 2 be done by like a resource manager to create what's pushed down but not interpret it?
It does a text translation, right? And it fills in parameters. I believe there's ways to specify callouts. So, you know, when you insert a parameter, it could call a method for resource allocation. So like for a gem port, you know, hey, you have a gem port specification with a method that calls out, which goes out, allocates that. I'm just trying to figure out a way that if there's something, if this works, great. If not, great. I just would hate to see each adapter having to write their own interpreter.
Yeah, well, it's certainly something we can investigate. You know, I'll make a note of that in the minutes. But yeah, so certainly something we can look at. Okay.
And if we use something like Jinja, then we know that it's got coverage by multiple languages too, which would be beneficial as we move forward.
Yeah, right. Okay. Any other comments, questions on this part of what the OLT is doing? I mean, so basically OLT, you know, gets the OpenFlow configuration through the iAdapter interface, and then it needs to go and get the technology profile from the KV store. It needs to go and based on that, it needs to go allocate some resources, alloc ID, and multiple gem ports potentially. And basically then, once it has all the information that's needed for this service instance, I mean, some of this information, you know, as in the comments here, may come from some port level configuration. And once it has all that information in the technology profile instance, it can store that off. And basically, the ONU then, once it has the information it needs, you know, from the meter bands and the book flow update, it needs to then go and, you know, wait for this instance to be there. Once the instance is there and it has the flow information, it can then go and use the OpenOMCI to go and generate the ME message sets to configure all this information down onto the ONU. The OLT obviously has to go and do its part, setting up the configuration for the flow on the OLT side of things as well. Okay. Any comments about that? Questions? Okay. Yeah. So again, some of the information, the algorithm for, you know, deriving some of the upstream and downstream bandwidth parameters are described in the white paper. That's part of the one of the attachments to that 731 Vol 731 Jira story. Okay. Let's see. Assume that the physical OT chassis will allocate an ONU. So as part of resource management, there's a story, Vol 948, that talks about resource management. So here's a task that's part of 731 that describes resource management. And in this case, for XPON, it's basically saying it will provide resource management for ALEC IDs, for XGEM port IDs, and potentially it can also do ONU IDs, although right now, basically OLT is allocating the ONU ID as it brings up the ONU into range it in, and that's passed upstream as part of the discovery thing. So we don't. If you want to override that, we can, but right now we don't really need to do that. So here it just describes the legal range. Yeah. And then OT adapter use a combination of OpenFlow, logical port, technology profile, flow ID. Oh, so the way that we're addressing things in the KV store, so for the technology profile itself, we're basically using the technology profile ID. We're using technology, and that basically uniquely identifies an entry in the KV store. For the technology profile instance, we also need to add the logical port ID. I was thinking about using the flow ID, but then I took that off because I think just using the port ID and the technology and the TID gives you uniqueness on that particular logical port. In the future, we may want to use the same technology profile ID multiple times on the same port, in which case we have to add another discriminator, which could be the Q tag. So because if it's a business type service, then we have to match on the uni port for something, and it's likely going to be some kind of Q tag type piece of information that discriminates the different service flows. So we could use that to create a different instance in the KV store in the future. Right now, everything goes to the same instance on a given logical port. Okay. And well, 759, ONU adapter uses a service-specific technology profile instance created by the OLT and OpenFlow rules passed by the flow decomposer to derive the OMSI message set. So this is one that we talked about a little bit before. Was the ONU basically is waiting for the technology profile instance to be created, and until it gets the OpenFlow rules, and then it uses that information to generate the OMCI messages. Does that make sense?
Yeah, I think so.
Okay. So these are basically, I mean, there's another story as well for the edge core adapter. That's basically, it's the same as the OpenOLT adapter one. So, are there any other questions that we should discuss? Were there any other issues outstanding around technology profiles? I mean, we kind of started documenting some of this on the wiki as well. So if you take a look at the wiki and comment on anything that you see in there around the technology profile instances, technology profiles themselves, and creating and managing those. Okay. So if there's any other issues or architectural issues we need to deal with, or any other questions, you can just put that out to Volta to discuss, and we can take those up. Well, was there anything from you, Gamzee? I don't know if you're still on, but any other questions that we didn't address here?
Yeah, addressed all.
Yeah. Okay.
Well, I guess one question is, do you know about during what sprints various things are going to be starting to roll out, and what dependencies you might have on OpenOMCI?
So I guess the initial work that needs to get done, I think, is basically the the ONOS level and Volta core level, right? We really need to be able to create the technology profiles in the system and support the meter bands, and then we need to be able to provision or configure the default technology profile for authentication that needs to come down to the OLTs. So, I mean, once we have the technology profiles within the core that can be passed down to the adapters, at that point we can start using that information to generate the OMCI messages. So I think basically having the ONOS apps updated, having the Volta core done is the first part to getting this working. The adapters can basically have default ones if the old OpenOLT adapter needs to start working right away, so they can just have defaults that they can create for that. So I guess there's another meeting scheduled this week, I think, to talk about the OpenOMCI as well, right?
Yeah, I'm not aware of one, but I guess we could have one.
Yeah, I think we probably should have one and talk about how we use the technology profile instance information and the flow information in the ONU adapter, and how that is used to, I guess, create sets of the OMCI MEs to configure the ONU.
Okay.
Is that kind of pretty clear in your mind, Chip, right now? Or
yeah, I was just wondering, because I'm going on vacation for 2 weeks starting next week. I just wanted to make sure I'm not going to hold anyone up, or if there's anything I can do ahead of time, just let me know. But along that is the OpenOMCI to set up a data service on the ADTRAN ONU. I've converted that over to use the OpenOMCI task and started to break down the dependencies and document the dependencies between the various MEs, just so that when we do get into that, we can hopefully find something common among several of the ONUs, so that we can have one way to, one set of code to create the MEs, if possible.
Yeah, that would be really useful. But so I think if we look at what information is available from the technology profile instance and the OpenFlow messages, I mean, this, in theory, this should give everything, every parameter we're going to need to fill out those MEs to configure the ONU, right? I mean, so there should be a way to, convert this into the OMCI MEs that we need.
Okay. Yeah, I'll try to go through what we have right now, and I'll try to map them to the appropriate MEs, and we'll send you some email just so that you have information too.
Okay, yeah, that'd be great. Did you want to? Could we have a meeting to kind of discuss that? You're going on vacation next week for 2 weeks.
Yeah, starting the 25th until the 6th.
Okay. Is it maybe could we have like a short meeting on Friday maybe just to?
Sure, sure, and I'll try to have something put together by then, or at least a good chunk started.
Okay. Okay. Well, thank you, everyone. Unless there's other questions or comments.
Just a question for me then. Do you need me to look for a meeting time on Friday then?
Yeah. If you.
Or was that okay?
That'd be great. I think I'm pretty much free most any time.
Is Friday okay for you, Chip, or are you getting ready
Oh yeah,
to go?
as long as it's not 4 o'clock on Friday, because I don't know if I'll be.
Yeah. In the morning would be good.
Yeah, I'm free all day Friday, so Central Time.
Okay. All right.
Okay, so Sean, I'll coordinate with you and Chip on a meeting time, and then we can let the wider community, know if they'd like to attend as well. Okay.
Sounds good. Thank you, everyone.
Thanks. I'll go ahead and stop the recording.